Okay, so we are back with part 3 of our barcode project. What we're going to do now is we're going to be changing several things. And first off, to address some things you may see on the screen that are different. Now you're going to see this master thing here for me, and that's because what I've done is I've initiated this as a Git repo, and I'm using Git to handle my versioning. And the reason I'm doing that is because occasionally in the video process you make errors or mistakes, and it's nice to be able to revert your code back to when you started the video so you don't have to hold Control Z for 38 seconds and then still run out of buffer. So the only thing that we've changed so far is I've done the Git init, and we're not going to cover that in this video. We'll cover Git in a very different video. But this base URL here, you'll see that I split it into 2 lines. And by doing that, all I did was simply close that, put in a backslash, and put the rest of it down here. And that's because this line here is like an imaginary margin. A lot of IDEs are starting to put these in where basically it's a suggested breakpoint. Your code should not go past this line, and mainly because as other people read your code, they don't want to have to grab the scroll bar and scroll back and forth to read your code. It's just much easier to put on multiple lines, and Python and many other things do support that. So anyway, when we left off, we had the get barcode, we had the open file and all that, and this is great. And I'm sure that somebody was already screaming at the last video going, "You're doing it wrong." And it's true, I was doing the open file incorrect. I'm doing that the quick way, and now I'm going to introduce a better way to do that. So what we're going to do is we're going to be refactoring this. And refactoring is a programming term that simply means changing or editing your previously working function. So in this case, we're going to close the code folding there so that it's folded up so we don't see it. And we're going to be changing this open file again. And we're going to be doing this for a few reasons, but mainly the fact that this is a CSV file, and Python has a module that's built in already for handling CSV files so that we don't have to manually parse the data. And it gives us some other interesting things. So we're going to just simply import CSV up here, okay? And this is built into Python. There's no pip installing or anything like that, okay? And down here, we're going to change this F object to a CSV object. And the only reason I'm doing that is for readability, okay? And this line here, we're going to just comment out we don't need it. And instead, what we're going to do is we're going to say file data equals a CSV dot dict-reader, okay? And then your CSV file and delimiter equals that. Your typical, comma. And what this is doing is it's basically using the CSV dictionary reader to read this data into a dictionary. Now, file data up here, we're going to change that to a dictionary, which is 2 curly brackets. Now, there's a big difference between a list and a dictionary. A list is indexed but not keyed, and the difference there is an index is only used by a number system. So if you have a row of data, we'll call it this data here, right? So if this line was indexed, then student data would be index 0, district ID would be indexed 1, index 2, 3, and 4, and that would be your index, okay? Keyed, on the other hand, is something more like this, and you don't need to type this. This is just simply to explain. You could say name equals snod grass, right? And then ID equals their ID number. And this is a reference of keyed. So you can access these easily by simply using a key, or in this case, a name. Whereas with an index, you got to go by 0, 1, 2, 3, 4, and it's very confusing. So dictionaries are more handy in the fact that they do that. The other thing is that dictionaries are easy for you to add in data. So what we're going to do now is we're going to, now that we got this, we don't need this anymore. We can get rid of it. Now that file data, this is actually going to just be student data this time. Why is it? Oh, it's probably because it's shadowed from somewhere else, right? Yes. So student data is referenced outside of this loop, so it's okay. It's outside the function. It's fine. So student data gets read in. Okay. You can name this anything, honestly, but we'll leave it as student data. And now what we're going to do is we're going to introduce a new structure for you guys called a loop, and we're going to simply say for a row in student data. Okay. And the other thing we're going to need is we're going to need a counter. Okay, and a counter is just that. It is simply a variable that we will be incrementing each loop in this row. For each row, we're going to be adding a 1. So we're going to say x plus equals 1. Now, that plus equals can be written another way. You could simply say x equals x plus 1. And that's technically correct as well. However, this one is more, and again, I'm going to use that word Pythonic. It's just it is the way that Python programmers tend to do. It's less to type, it's easier to read in our opinion, or as easy to read, not easier. This is the easiest right here, but we'll get rid of that. So, and the only reason we have this X object is to count what row number we're on. And so now, because we don't care about the header of that file, we're going to say if x equals 1, and notice the double equals here. This is a comparator. If you did a single equals, you would be assigning the variable. In this case, we're simply comparing the variable. We're saying if x equals 1, which means that if we are on the first row, right, we're going to continue, which simply means skip what we're doing and go back to the next item in the iteration. Okay, so the next row. And so now what we're going to do is we're going to simply print the row so we can see what kind of data we have. And we will do that by doing python main.py. Let's scroll down here and make sure that, let's get rid of this get barcode thing. We don't need to see that. Simply opening the file there, and opening the file will not only open it, but it will also iterate over this row, and when we run it, we should see all of our student names. And now you will see that it's actually a dictionary. Okay, so we have each student name here, and we have our district ID and our pass. Now the cool thing about doing it this way, if you had tried to manually do a comma separator by saying, hey, split this string on these things, you're going to get problems because remember we have a comma in this one, but because it's encapsulated, right, it was encapsulated in our data. If you noticed, we had quotes around it. The CSV importer realized that and does that already for us. So it does all the escaping and everything else, and so now we can actually access each of these by a key, in this case district ID, pass, grade, and those things. So this is much easier for us to do. Now our file data up here, I've changed my mind. I'm going to make it a list again, okay? And the reason I'm going to make it a list is we're going to make it a list of dictionaries because each of these is a dictionary. You can tell because it's got the curly brackets. And so what we're going to do here is we're going to say file data dot append, which simply means add to this list, and we're going to say append the row. And when we do that, there's a reason we do that. It's because this dict reader here, this object, lives inside this function. It can't go outside of that function. So if you were to return the student data and not do this parsing and not add it to a list up here, if you were just to return this and try to access it, the dict reader is going to say, well, the file is closed. And the reason the file is closed is because, again, this with here, we're saying do these things while it's open and then close it. So, and then we exit the actual the function. So we lose the variable of this because there is no file that's open, because we exited out of the with and we've also exited out of the function. So we got a double whammy. So instead, we're simply adding these items to our file data, okay? Just adding to it each time, and this loop will continue until that runs out of student data. So it already knows how many rows there are. In this case, there's 3. And you're probably wondering, how did you get 3, Phil? Well, I didn't tell you guys that I copy pasted some stuff in here. That's totally my bad. You can do the same. Again, this is why I went back to the versioning idea, because I've messed up twice in this video, and one time I may have said a curse word very loud. Anyway, so going back to reality. So now this function is hopefully finished. I don't know if we're going to come back to it or not, honestly, but we shouldn't have to. So this open file here, and now we have our student data down here, and we know it's being returned, so we can go ahead and print that and make sure that it is doing what we think. And here we see a very common thing whenever you have a list of dictionaries. So we have the list starting with the square bracket, and then we have our squiggly bracket, which our curly braces are used to define a dictionary. So we have a dictionary here, and then another dictionary, and then another one, and we continue until it's empty. And this is important because now we're going to do another loop, okay? Because now we're kind of in our main program loop, right? These are functions. These are separate from the main program. When the program runs, it's going to come in here, and it's going to do things. We're also going to do another, I guess I want to say, the convention. So we're going to now say if name, I'm sorry. Is it that? No. Yes, it was that. Okay, so if underscore underscore name underscore underscore equals main. And this is not referring to main, the file name. This is saying the main entry point to our file. And we get into namespaces and whatnot much later on in the series. I don't want to get into that now. For now, just understand that the main entry point is the special underscore underscore main. Okay, the name of the entry point you're in. If you were to do it up here, I don't know if it returns anything or not different, honestly, because it's in the same name. Same namespace. But anyway, different files can have different namespaces. We'll get into that later. It's complicated. It's very complicated, and you don't need to get into it. So what we're going to do now is we're going to edit this comment and say get CSV data. Okay, and we're inside an if, so we need to push this over a little bit. All right, and this again is strictly because it's convention. It's not a good idea in your Python to just have things just run. It's better to have everything inside a structure so that you can control the flow of things. Because if you have something down here that you weren't quite sure was supposed to be there, and maybe it should be up here, so it's just better to have everything structured. Just trust me. So we still have our student data. Nothing's changed because the name is main, so we know for a fact this is going to run. And just to make sure, we'll simply run it again and we get the same result. Now notice that this has changed, the green and the yellow. Yellow is letting me know that I've modified the files. That's all it means. Yours probably won't have that unless you're running Git, so don't worry about it. So now we have our student data, and now we can do another loop and say for S in student data. Okay, so each S is a student data, and we're going to simply say print the S and then square bracket and quote for a string, and we're going to say district ID. Okay, and we're going to hide this when we don't need it. So basically, we should get a listing of the student IDs, and this is one way to do it. I'm going to show you another way in a moment. Okay, so now we get each student ID. which is nice. We don't have to, we're just simply parsing more and more data. Python is very adept at parsing data. It's very easy to do, especially when you've got such great things such as uh, a dictionary and a list, which is very different because, like in PHP, for instance, everything is an array, which an array is kind of like a list, but you can also have keyed lists, which are arrays, and you can have multi-dimensional arrays, which is very complicated. Um, and it's one of the things that I really enjoy about Python is how easy it is to access data. So in this case, we're going to say this. Now, this is a perfectly fine way of doing it. Nothing wrong with this, okay? But it's not really got any error checking involved, because what if the student, what if the dict, what if the dict, what if the district ID, what if it doesn't exist? Right? We assume it exists here, but we don't know if it does or not. One of the things that a good programmer does is they constantly ask questions. What if the user does that? What if the user does this? And remember that the universe and you are locked in this eternal struggle. You being a programmer, you are trying to make something that is idiot-proof. Okay? You want it to work every time. The universe, on the other hand, is in a constant struggle to produce a better idiot, and typically they win. So you've got to do as much error checking as possible to combat the idiot that is between the computer and the chair. Okay, and I am an idiot. I do it all the time. I mess myself up all the time. It happens. I like to leave them in these videos to show you that even somebody who's been programming for 10 plus years, I'm still an idiot. I still make mistakes, and it's common. Okay? There's a very famous meme, and I'm sorry I'm taking a moment to ramble here, but there's a very famous meme of, like, man, you think you're a genius programmer, and then the minute it breaks, you're like, man, I know nothing. I am horrible. And then you find the one semicolon, and you're like, ha, I'm a genius again. Yeah. There's nothing better than when you type code the first time straight from memory or straight without error checking along the way, and you just kind of run it and it works, and you're like, yes, I am a god. Witness me. But then, you break it instantly after that. So anyway, that's kind of an encouragement for everyone who's watching this, especially if you're programming for the first time or you're not really a typical programmer. The complex that people get of, oh man, I'm horrible at this. Look, everyone's horrible. We all started the same boat. Okay, nobody woke up one morning when they were born and said, I know how to program. I mean, maybe Linus Torvalds did, but aside from him, there's really not many other people. So anyway, back to programming. Sorry for my minute of rambling. So what we're going to do now is we're going to do some error checking on this. Instead of S and then accessing the key directly, because this could give us an error, instead we're going to say x.get, which is something you can do on a dictionary. And you're saying get the district ID. It's a safer way of accessing it. Now, the other reason, or the main reason it's safer, is you can also supply a default value to return. And in this case, the default value to return will be 0. And the reason it's 0, can anyone guess? The main reason it's 0 is we're expecting this to be an integer and this to be an integer. So the district ID should be an integer, and this should be an integer. And right now they're actually strings. Even though they're numbers, they're a number of string. You can tell down here it's got encapsulation of quotes. So we have to typecast this. Okay, so we're going to say int. We're going to put in another thing here. And we're going to put in some spaces just to make things easier for everyone to read. Okay. And it's going to complain, but I'm only doing this temporarily. So get, right, the s.get is going to give us whatever's in that district ID field. If it's not there, or it doesn't, or it's empty, it'll come back with if it's empty, it'll still be there, so it'll come back with empty, but in this case, it'll come back with 0. And we're going to get rid of that and that. And then we'll get rid of this. This is typecasting and basically saying we want to force this to be an integer. Okay, we want it to be a number. And now when we do it, we will see the same thing, nothing different. But let's, yeah, I'm not gonna make it complicated. We'll leave it like the way it is. Okay. So yes, you could do a try and exception block here, and that's totally fine. However, it's longer code. It's much easier just to say s.get and to supply a default of 0. So we will do that. Now, you don't have to have this as that. You can actually just have it as a 0. And the reasoning is that the int force typecast will force it to be a 0 anyway. So either way works. I'm going to leave it the way it is there because that's more correct. Okay. And now, since we have this district ID, right, and we know what it is, we can say their ID number equals this. And now we can say get barcode, right? And we're going to pass that ID number to it as the district ID. Okay. Now, get barcode, if you remember correctly, up here we worked on it last, it's not returning anything. So that's why this is going to have some issues and complain. And the ID number here, it's saying it shadows from elsewhere, somewhere else. I'm not sure where. Anyway, this barcode does not return anything, so we need to return that R content. And you're probably wondering, well, wait a minute. What if R content isn't created? Right? Because that's what it's saying. It may not be assigned, because in this exception block here, we're passing over it and we're just saying print, and we're not returning anything. We're not changing what R content is. The R object doesn't even exist inside this. It's inside the try up here, but it's not done inside the exception. So what we're going to do is we're going to instead say here, return false. Now, that's okay, but not the best thing. We really need to send some content, and the content in this case is going to be an empty string. Notice that my false was also capital F. Python's the only language that I know of that actually has a capital F for false and capital T for true, because they're considered objects instead of just names. Anyway, so now we're returning content, which is a string. It is a bytecode string, but it is still a string. And this is also a string. Okay, so we're returning the same thing out of both ways that we can return. Now you could actually create the R content object up here, and it's just much easier to do it this way. Trust me. So now now we're going to say our barcode equals the get barcode, right? And let's go ahead and just print that barcode. Okay. We're going to print that barcode, and we're going to look at it, and it's going to hit it. And there's all of our stuff, and it looped through everything. It looped through it all times. So we're going through our loop. We're getting 3 barcodes. Everything's great. Okay, but now we need to save this barcode as something. And we're going to make a very quick and dirty save function. We'll go back next video and correct it even more. But for right now, we're just going to do a quick save function. And we're going to put it right here. And we're going to say define save file. Guess what it's going to do? And whenever you're saving data, you need the data itself, right, which is going to be a string, and the file name, which is also a string. Okay. And in this case, we're going to do try real quick with open, right? And we're going to open up that file name. Now we're going to do a different operation. We're not reading. Reading is an R. We're going to be writing, which is a W. But we're not writing text. We're writing bytecode. So we need to say B for bytes. Okay. And then we're going to say as F. Okay. F.write. We're going to be writing what? We're going to be writing our data. Okay. And then we're going to return true. And as an exception here, we're just going to say exception as E, same as last time, nothing big. And matter of fact, we'll come up here and we will copy this print line, and I will paste it down here because I'm unable to save that file due to error. And look, I've saved myself some time. So really quickly, we have that save file, right? And now we're going to say, instead of print the barcode, we're going to say save the file of our barcode data, and our file name is going to be test.gif. And you're probably saying, well, Phil, we've got multiple test.gifs, and that's true, we do. So what we're going to do is we're going to make a file name down here, and that file name is going to be our, let's do id.gif, okay? But that ID is going to be changed constantly. So we're going to make it a string replacement and say ID equals ID. Let's get rid of that ID thing because it's complicated. Let's just leave it like that. Okay, so, and again, I like my code double spaced because I'm weird. And there we go. So we're going to be saving that file. The data we're passing is barcode, and the file name is that. And with 3 point something, you can actually say data equals barcode, right? And the file name equals the file name. And the reason you can do that is because of these type hints that we've done up here, data and file name. So you can actually do it this way and supply them in different order if you wanted. But most people will probably think that's weird, so we'll get rid of that. It's not needed. Most people don't use that. It is a helpful function at times, though. So, all of that being said and done, we're at 26 minutes. Let's see if this will write our file. Now, this test.gif, guess what that was? That was a test from earlier. We're going to be deleting that. You don't have that, hopefully. Otherwise, you've been attacking my computer and things would be bad for me. So now we're going to say for each row, we're going to move the pseudocode up to here, right? And we'll grab some data and save it. Okay. This is exciting. We're getting really close to being finished with this whole project. We have just to generate the file and display it, which is actually pretty simple. So this is complaining because it needs to have less space. And I know you're like, just run it. I want to see it run. And it'll run in a second. Hold on. Now this file name is being used all over the place, especially down here. And this is why encapsulating things inside functions is helpful, because it does give you that split. Anyway, I'm going to run the program now. So let's clear this so we can see. And now we're going to do that. All good, all good, all good, 3 times. And we update, and look at that. We have 3 GIF files. And if we open them up, each of them is our barcode, which is really cool, isn't it? So there. Now we have read all of our student ID data, right? We've opened the file, we've got that barcode, we've saved the file over and over. We have individual files here with those student IDs, those district ID numbers. And now all we have to do is generate the HTML file. And for those of you who don't know HTML, this will be a fun experience. And then we're going to be opening up the browser, which is very simple. You would be amazed at how easy it is to open the default browser inside Python. And we're going to go ahead and do one other thing. We're going to execute a pip command. I didn't do this last time because we ran out of time. I've got about 2 minutes. So request, right? Remember we installed that by saying pip install request. How do we let others know if they grab this code that they need that request object? I'll tell you. So pip has a command called freeze. And what that does is it outputs all of the things that were loaded with pip. What we're going to do is we're going to do pip freeze and then direct that output into a file called requirements.txt, which is a standard name. Most people use that name. And you'll see our requirements text is basically just this. And pip has a way for people when they're importing this project, they can just simply say pip install -r and then the requirements.txt, and it would actually install all the packages that are needed right out the gate. And again, this is all going back to making things scriptable and easy to work with. So we've covered a lot today. We've gone through and we've refactored our open file and changed it into a new module type, which is a CSV. That also made it a dictionary, which is a new type of document or new type of variable that you guys haven't, well, we haven't covered here. We also have quickly made a save file function, which writes in a bytecode format, which is also very new for you guys. We've also gone over a for structure, which is also yet again, a new thing. We've covered a lot of new things in here. And because of that, I highly encourage you to work with on your own, play around with some different structures, try to exercise this knowledge. The more you use it, the easier it is to remember. Okay? We're dead at the 30-second mark, or 30-minute mark. I keep saying 30-second. 30-minute mark. So I'm going to shut my mouth and again do that like, subscribe, share thing. Let everyone know kind of what we're doing. And we will be releasing this next video here soon. I'm actually going to stop where I'm at. I want to go ahead and record the next part of the series and get that done because I need to have this program done relatively quickly. If you guys like these kind of videos and you want to continue in the same vein, maybe we'll get a little more advanced each time. I have another project that I need to work on. So, and this one is like huge. It's a full-on thing. So you'll learn a lot. But anyway, I'm going to stop where we're at now. And again, thank you for your time.